Thank you, and welcome to the first in a series of webinars on Lab Automation is Inevitable. Are you ready? Before we actually get into the subject matter, let me just tell you a bit about our organization. Our primary purpose is to advance the practice of laboratory automation. We're doing that through educational programs, developing methodologies and standards work, and membership, building a community of people who are interested in the same subject. We see lab automation as a means of transforming laboratory work. We're carrying out our educational program through webinars such as this, which are a joint effort between the Institute and Lab Manager magazine. You can find out more information about it through the URL. In addition, we've provided our first in a series of video courses, this one focused on IT professionals, so that they can get a better understanding of what laboratory work is like and how to go off and support the people, the scientists working in laboratories. And as I mentioned, we're a membership organization, and it's something you may want to look into. Most courses in laboratory automation focus on training for specific technologies and applications, such as the one shown on the right-hand side of the screen. Our approach is quite different. We look at laboratory automation and technology management in a really different way. The graphic on the right, which is right now probably too small for you to see in any detail, will give you an idea of the breadth of subjects that need to be understood to do an effective job of dealing with laboratory technology. If you want to get a full-size diagram, you can download it from the URL that's shown on the screen. We're going to be using this as a guide going through the rest of this presentation, taking it a piece at a time, to give you an idea of exactly what kind of things we're going to be dealing with over the next few sessions. In this seminar series, we're going to start by looking at lab work, what kind of things are actually done in laboratories, the tasks and functions that can be found. Then we're going to do a breakdown of the technologies that can be used to address those requirements. And finally, in the last two sessions in January, we'll take a look at the actual products and technologies that can be used to implement successful solutions. During this series, we're going to look in detail at what lab automation is, and it's probably quite a bit different than most people think about. Why it's important, how to do planning, the types of implementations that are possible for laboratory automation systems, and some of them are things you haven't heard about before. Another thing that's fairly important that we're going to look at is how people's jobs are going to change and the skills that are being needed to work in laboratory systems. Then the products and technologies, and we'll also be looking at special issues, which is how to go about purchasing systems, issues such as integration that find their way into most product requirements documents, and the idea of a paperless laboratory that's very popular, particularly in marketing, but is a lot of hype too. And during this course, we're going to be separating the marketing hype from reality. You'll benefit by understanding how the pieces fit, including technology and training requirements. You'll begin to see how to formulate a plan and why plans are really that important. It'll give you a basis for presenting those plans to upper management and getting their support and approval. I'd like to go back to the title of this course. We chose it simply to emphasize the fact that laboratory automation and intelligent systems are part of everyday life in working with a laboratory. It's really hard to buy a piece of equipment that doesn't have a chip or software associated with it or some kind of communications built in, with the idea of making it easier to use, to streamline your operations and improve efficiency, or manage intellectual property. The real issue is how you go about using these tools effectively. It's not like one-plussing a piece of equipment that you already have in your laboratory, buying the next model that has a little bit more capability than the previous one. It's really a change in mindset on how you deal with laboratory systems. The laboratory sources of data wind up going into things such as laboratory information management systems, instrument data systems, electronic laboratory notebooks, and scientific data management systems. But it isn't simply a one-way pass-through of information from wherever the data is coming from to one of those pieces of software. These pieces of software are often interconnected. So as a result, you can gain a fair amount of synergism by doing the planning necessary, by picking the right products, but you really have to understand what it is you're looking at in order to do that. We're going to begin, as I said before, looking at laboratory functions. First, we're going to break them down into two groups of management and work execution. In terms of management, lab managers have to worry about personnel issues, all of the things that are shown on the screen. In particular, we're going to be concerned about job descriptions and the educational requirements needed to work with laboratory systems. And as you'll see in a few slides, those things have changed quite a bit. Managers also have to worry about resources, management of work, and relationships to other group. The work that's done in laboratories is done not just for the laboratory's use itself, but it's shared with other groups. And how technology impacts that is a fairly serious issue. In addition to dealing with resources, it's a matter of worrying about equipment inventories, materials inventories, reference materials for manuals, libraries, hazardous materials, procedures, and things such as this. And also doing a lot of work on planning, budgeting, hiring. We're going to be spending a fair amount of time on that in session 4. There's also the management of work, schedules and priorities, looking at samples, what work has to get done, chains of custody, processing requirements, doing work lists, intellectual property management, and also, which is something which is very important across all industries, are things such as regulatory and compliance. Finally, we deal with work execution, how experimental methods are developed, documented, trained, and validated, recording observations as a result of experimental work, experiment and method execution, how are procedures being done, are they being done manually or automatically, and data analysis and results reporting. All of those are functions that goes on in laboratories that can be dealt with and improved by the use of various technologies. We're now going to take a look at this diagram in pieces and take a look at how those technologies are organized. This diagram is unique to the Institute's work. You're not going to find it anywhere else. The major categories that we're dealing with are the ones shown on the screen. Management issues, classes of laboratory automation implementations, experimental methods, technologies that are specific to laboratory work, information technologies, the things that you depend upon working with your IT people, and systems integration, an increasingly important part of laboratory work. In terms of the management issues, there's planning. And once the planning is done, you have to deal with implementation, which means project management. People skills, defining policies and practices that guide the implementation of systems. If each project is done with its own set of guidelines, it's really hard to bring these projects together. Our approach, as we shall see in the management section in a couple weeks, talks about defining broad policies and practices to bring laboratory systems together under one set of rules so that it's easier to implement them and work the systems together. Mapping workflows. How is work moving in the laboratory? How are systems being used? Are there conflicts? Relationships with other groups, and also regulatory requirements again. One thing I want to look at, as we mentioned earlier, is the skills required. We did a survey with Lab Manager Association about 2 years ago, and out of that survey we found the points that show up on the screen. That lab automation is essential for most labs, but not all. There are some laboratories that simply can't use automated systems because of the nature of the samples. For example, people looking at lotions on human skin. People don't like their hands being put into automated equipment. They also found out that the skill set necessary to work with automated systems has changed significantly. If your training is 10 years old, you're going to find out your training is out of date. In the last few years, the sophistication of systems has changed significantly, and the training requirements has as well. That entry-level scientists are generally capable of working with hardware and software systems, but entry-level technicians often are not. The problem is that the people coming out of school, particularly with just bachelor's degrees, don't get good backgrounds in things such as laboratory automation, LIMS, ELNs, and other systems. In general, applicants for positions are not well qualified to work with automation. This is pretty much why we focused on education for a lot of our work, to raise the skill levels of people who want to work in laboratories. Classes of laboratory automation is something I've mentioned a couple times, and now we'll just take a brief look at them. Again, we're going to look at them in more detail in future sessions. Computer-controlled experiments is one. This is an area where sample preparation is dealt with, robotic systems, or where a computer is controlling an instrument that's running the experiment. Another one is computer-assisted lab work. Areas such as laboratory information management systems and electronic laboratory notebooks. This work has been done before by hand, before computer systems were available, but can be done a lot better using computer-assisted systems. And finally, the last one, something most people haven't heard much about, if at all, is the area of scientific manufacturing and production. If you take laboratory automation to its logical conclusion, you have a completely automated system from samples coming in through reports being generated, and that includes sample processing, data acquisition, analysis, and reporting. That basically is a manufacturing production system and can be designed that way, but needs to be managed a lot differently than most systems are. An area which is very important but which we can't say very much about in most industries is the issue of experimental methods. Most methods that are designed today are designed for people to do the work. They're manual methods. We need to learn how to convert them to automated systems, basically to build automation-ready kits, so that if you want to carry out a particular type of analysis, you have a list of the procedures and hardware and software and equipment necessary to make it work. Now that may sound like science fiction for a lot of people, but it does work in some industries. In the clinical industry in particular, a lot of work has been done because of standardization that allows clinicians to go off and specify equipment that is designed to work for particular types of analyses, and it works fairly well. Another area we need to deal with is that of lab-specific technologies. This is pretty much the high level, the top level of the structure, looking at all of the things you need to be aware of in dealing with laboratory automation and computing systems. Everything from data acquisition to robotics, where all your sample preparation is done, and you can see different types there, to informatics, process analysis, and process control and optimization. You may wonder why the last two are being included, but if you're here next week, you're going to find out that process analysis is a very important part of dealing with laboratory systems. I'm going to spend a fair amount of time working with those issues. One thing I'd like to spend a moment on is the area of laboratory informatics. Basically, informatics is a word that's been used to replace information technology. It just sounds better. It includes things such as scientific data management systems, lab execution systems, lab notebooks, multi-instrument data systems, laboratory information management systems, and data analysis systems. When those things first came on the scene, they had very specific functions, and the functions are listed on the right-hand side of the screen. As each one came out, they satisfied those functions, and then they morphed. Data instrument systems came out in the late 1960s, most notably from PerkinElmer, where they started working with tying computer systems to their laboratory instrumentation, spectrophotometers and chromatographs in particular. 10 years later, they were one of the principal vendors of laboratory information management systems that had a very specific focus, and that was on sample tracking, managing the laboratory. 10 years later, we started seeing things such as scientific data management systems and electronic laboratory notebooks come out. Again, they all had specific functions. SDMS and ELNs were focused primarily on record keeping. Because of what has happened in competitive pressures and customer requirements, those things have really changed a lot. If we look at the green area, electronic laboratory notebooks, we'll see Mathematica for mathematical work coming out of Wolfram Research back in the late 1980s as the first example of laboratory notebooks. LabTech Notebook came out a few years later for doing data acquisition and results recording. The really major advance in laboratory notebooks started in the late 1990s, and that's basically the genesis of what we're seeing today and what we're working with today. It started off primarily as a record-keeping facility, but expanded to include things as instrument data capture and test and execution. The people developing LIMS systems saw what was going on, saw how their market was being affected by other things coming in, and expanded the capabilities of their products to include things like instrument data capture, record keeping, test execution, and so on, as well as some of the other technologies. The end result is you have kind of a blur of capabilities. If you look at the marketing sheets for most of these products, you're going to see the same things listed, but they differ quite a bit in how they're implemented and how much work you have to do in using them. When you're dealing with product requirements, you've got to be very specific about what it is you really want to accomplish and really make sure you're looking at the same thing from different vendors, even though they're using the same words to describe them. In information technologies, this is your basic computer science stuff. Networks, client server systems, the kind of things that you're seeing on the screen and that you're familiar with. Now, some people may look at those and say, okay, that's the IT department's issue, not ours. It is your issue. If you're dealing with chromatography, some of the chromatography database systems that support multiple instruments and multiple users are client server systems. And how they work is going to have an impact on how your lab operates. Virtualization is a relatively new concept in laboratory work, but it's a computer science concept that has a lot of benefit for you. For example, if you have a piece of software running on an old machine sitting in the corner of the lab that you'd really like to get rid of, but you can't because you need that data, virtualization is a way of dealing with it. You can create a virtual copy of that machine, put it on a server, have access to it anytime you want, and get rid of the hardware. You can also use it as a means of training. You can create a virtualized version of a product that you're working on, have people work with it without touching the live system, gain some experience, make all the mistakes they want, and when they log off, it's gone. So are their mistakes. It's a good way of transitioning between a system that's been in place and a system that's being upgraded. It gives people the ability to work with the old system, learn about the new system, so when the new system comes online, they're already familiar with it. The last point is systems integration. The methods, standards, and systems that are necessary to make this work. Systems integration shows up on almost every product requirement list. Anytime people have a project, they want to integrate things. The question really is, are we there and are we capable of doing it? Again, that's something we're going to be looking at. So in total, this is what the matrix looks like for laboratory work. These are the kinds of things that you need to be familiar with and understand to use the technologies that are available to you today. Things that you see when you go to Pittsburgh Conference or SLAS or any of the European shows. This is where things fit. And the idea of this diagram is to give you an idea of the structure so you can see how things fit together. Using these advanced technologies isn't just a matter of purchasing products. It's really a change in mindset on how you deal with laboratory work. If you do it right, you can really transform lab operations, improving how things work, improving how people feel about their jobs, and also their job satisfaction and the quality of the work that comes out. If any of you play chess, you'll know that planning your moves ahead is essential to a winning strategy. The further you can go along in looking ahead, the better off you are. Some players only look ahead one move. Masters look ahead 3 or 4 moves, or maybe 5. At the beginning of a chess game, you have lots of choices. But as you make choices and moves, you start limiting the things that you can do further on. Each move imposes limitation and consequences for things that happen later on. The same thing holds true in lab automation. If you go off and buy products without a plan, you're going to find out that eventually you wind up with a bunch of mismatched products, and you have to go back to square one sometimes and start all over to build an integrated system. Planning is essential. You really have to approach this with an open mind and really do a thorough job. So over the next few months, we're going to help you do that. We're going to look again at what lab automation is and why it's important to your lab, the options for improving productivity. Management's role in laboratory automation is very important. Lab managers really have to get a grip on this stuff. Issues such as including integration of paperless systems, what's real and what isn't, and avoid chasing phantoms. Purchasing decisions. How do you navigate the laboratory informatics maze? How do you make good choices of products and combinations of products? And something that pops up every now and then, the idea of, do I build a system or do I buy it? We're going to address that. And then finally, the technologies and products used. This is a breakdown of what the schedule is going to be. Next week, we're going to look at why it's important, why lab automation is important, and what lab automation is, classes of implementation and skills. On October 16th, we're going to look at the options for improving productivity. The following session is going to look at management's role in lab automation. Once they've got the background on what lab automation is all about, we're going to start looking at how you actually do the planning work. And then finally, on the November 27th, we're going to look at things such as integration issues and paperless systems. In December, on purchasing decisions and how you go about looking at products and technology requirements in the build or buy issue. And then on session 7 and 8 in January, we're going to go into products. The 1-hour session each time, we're going to start looking at the various products and technologies that are available so you can understand how they all fit into the entire picture. I hope out of this session you have a good understanding of what goes into dealing with laboratory technologies, using them, implementing them, planning, and working with people. It's not just one plussing something that you already have. It's really looking at information flow, because this is where your information is going to wind up. And once you buy a product, changing them is very difficult.